All right, we're going to do a change of guard. Ladies, thank you very much.
Thank you.
Just as I told Ann and Megan, I applaud what it is that they did. I applaud what you two do. Outstanding. Are you ready, ma'am? We make the switch. All right, so we are going to switch gears now. We're going to be talking about material circularity, focusing on life cycle benefits of food waste composting. And Malak is going to give us an overview of what she is doing. So with that, ma'am, turn it over to you.
All right, let me make sure this works. It does. All right. Nice, everybody. Nice to meet everybody again. Again, my name is Malak Anshassi. I'm an assistant professor here at Florida Polytechnic University. I actually am within the Department of Environmental Engineering, and I have my two undergrad researchers in the back, Elise and Caleb. They've helped provide a lot of the data you're going to see today. This research is funded by the Hinckley Center for Solid and Hazardous Waste Management. Some of you are extremely familiar with it, and some of you maybe not. So I wanted to give you a quick kind of brief overview of what the organization is. They are a state-funded agency, and they provide a lot of great information to the general public, as well as provide funding to professors like myself, where we're able to actually work on important topics within the state of Florida that deal with waste management. And that research is really monumental because it actually provides a platform for all the different types of stakeholders like yourselves, as well as people like me, to actually connect and make research more practical than just living in its own little bubble, which it usually does. So that's kind of some really great things about the Hinckley Center. And as far as what this research topic is, it actually covers more than just food waste. It looks at 3 material streams that are commonly found in our residential waste stream that happen to be a problem. So if you could think of what they are, definitely food waste, because obviously we're here for the sake of food waste. But then we have textiles as well as glass. So these are kind of the problem child or children of the waste streams across not only here in Florida, but also across the US, and I'd even argue internationally. For many reasons, it's just harder to be able to capture those waste streams and actually make them into new materials, or to actually just use them and be able to find a direct reuse for them. So this research is really focusing on looking at what are ways that we can look at material circularity. I know that's a buzzword, but you'll learn a lot about what that means in a second. But looking at material circularity for textiles, for food waste, and for glass. And today I'm going to focus on just the food waste description, but to give you kind of some overview as to why this is important. So globally, food waste, we have 1.3 billion tons. Textiles, over 92 million tons, and in just the US alone, 11 million tons of glass. So for starters, they're huge waste streams. They are usually waste streams that are oftentimes also very heavy in their weight. So they play an important role on the recycling rate if you're still capturing it based on that mass flow. They're a big portion going to come from the residential waste streams. And across the supply chain, we see them from different types of just inefficiencies and why they're generated as a waste, or maybe they're just products that haven't met the direct quota or the direct quality that you want so that you can actually be able to sell them. So there's lots of reasons why these 3 are important. For us who are living in the waste management world, we care about them from the perspectives that they're occupying our landfill. Not only are they doing that, but they're going to be degrading and releasing some emissions, which are going to add more on to the reasons why you want to take care of it. The resource is wasted. If you're just going to throw it in and incinerate it, you're now kind of destroying what it once used to be and not be able to actually capture it and to be able to reuse it once again. And then just supply chain issues associated with distribution, with us as consumers maybe not being so wise and trying to purchase more and more when we already have what we need, or find ways to be able to actually use them and reuse them. So again, focusing on the idea of material circularity. So this is a buzzword that I think people oftentimes like to throw out without actually explaining what that means. And I want to give you at least one definition that you can leave today with and feel very comfortable with what material circularity looks like. So this is a diagram from one of the, I want to say, EPA documents that describes where we're getting our materials from. Typically, they're going to be mined from the earth. They're going to be extracted from our different types of kind of resources that are available to us in different parts of the world. They'll be used and designed, and as part of that design, maybe you'll think about, is there a way for me to partially recover it later on once it's done being used? And if it's going to be partially recovered or completely recovered, what could it actually turn into? And that turning it back into something new, kind of moving away from a take, make, and dispose kind of economy to what is a way for us to be more circular, so we can actually find a way to actually use this over and over again. So this is the idea behind material circularity and why we want to try and include this as part of our definitions and as ways for us to actually measure it. So I'm an environmental engineer, which means we look at things a little bit more technically, maybe with more numbers and a few other fancy charts and figures. One thing that we like to do is utilize different types of tools to be able to get a measure for what our environmental impacts could be. Oftentimes, the main tool to do that is by looking across the entire life cycle. So you're going to take a material and you're going to make it, you're going to use it, it's going to now come at its end of life. What's going to happen to it once it's reached its end of life? What can you actually decide that makes improvements to it, where you can make a decision that affects its environmental impacts? So some of the impacts you guys have probably heard before, things like global warming potential, all of those different types of indicators, those environmental kind of impacts, those are all going to be measured somehow, and the main way that you can measure it is using this concept of life cycle assessment. So life cycle assessment gives you a tool to be able to do that. And what we're going to do as part of this research is look at what happens when you take your food waste, you're able to capture it and be able to actually utilize it as a new resource. What is the environmental benefits, the avoidances are we going to gain from doing that? So that's one thing that we kind of want to look at. So in terms of implementing circularity, you need to start with what is the current system? What does it actually look like? You can't just say you're going to implement it when you haven't actually decided what that system should be like in the first place. So as far as what we're looking at in the screen, you'll see there's one for glass, for textiles, and for food. I'm going to focus on the food one in a second and kind of dive a little bit deeper into it. But some ideas for material circularity is essentially what we've just heard our wonderful morning from our great presenters. They've talked about all the different types of ways that we could take our food before it becomes even food waste and be able to use it upstream before it even enters into the end of life. But unfortunately, there's still a big fraction of that food that becomes wasted, and we need to be able to prioritize and find more kind of cost-effective, environmentally effective ways to bring it into a better kind of management and better usage. So this is kind of our current system. You have food that's in your curbside waste stream. It's going to end up at a landfill most likely. If you live in a county in Florida that has a waste-to-energy facility, some of that food will make its way there too, and it'll also be combusted and disposed of. So there's a lot of challenges with recycling food waste, because remember, now it's included the waste at the end of that term. It's not just food that can be recovered, it's wasted food. What can we do to be able to prioritize its recovery? So some of the challenges are just with logistics. We've been having a lot of great conversations with places across the country that do recover food waste, for example, in California and Oregon. And they've talked about some of the difficulties that they've had with just implementing the different truck types, the frequency, the bins, and obviously we're in Florida, it's very hot, it's very wet. That's also going to be more of an issue, and I'm sure we'll hear more from transportation and logistics from O-Town in a few. But that's one of the biggest issues. There's also a really big misunderstanding of the benefits. Why would I want to take food that's wasted and then produce a compost product from it or an alternative product from it? What is that actually going to, what value is that going to add? oftentimes that value isn't really physically seen because it might be in terms of soil nutrients. You don't really see the nitrogen, you can't really see the phosphorus impacts, but you can see the benefits if you take that and you're able to use it for gardening or some type of other application. And then also other regulations in terms of how do you even manage food waste? What definitions does it fall under? And we've heard from a lot of counties and also from a lot of just composting facilities that do exist in the state that there's so much differences in definitions that it makes it really hard to be able to capture what can be done once you're actually having food that's wasted go into these better managements. So our scope, we came up with a very specific scope because we want to be able to identify what is the environmental benefits associated with an alternative system. So we looked at this system right now. We have a compost bin that's going to be given out to residents. This is all hypothetical. There's no current regulation or rules in mind right now that are going to require at-home composting. But we're going to think about what's going to be the benefits of providing a compost bin to a resident. Now it's going to be collected at a certain type of time and day and a certain truck, and then it's going to make its way into a compost facility. That compost facility is going to be located about 20 miles away, and it's going to produce USA Compost Council certified, which is referred to STA certified compost, through aerated stack piles. All of these very specifics are important for us because when we look at the environmental impacts, we want to be able to actually describe it as it relates to a very specific situation. So that's kind of our goal. Our project goals are not only to look at the environmental impacts and be able to kind of get a sense of what are the differences in markets that already exist within Florida, but it's also to be able to consider the cost. So if you're a resident, what is going to be the new additional cost to you to be able to have at-home composting so that you could also get a sense of what is the economics of it? And then kind of finally bringing it all together, what is going to be the benefits from both an economic and environmental through our project modeling to see what happens with that food waste. So there's some results we've already started collecting. I know this is kind of a small screen, so I apologize for the smaller wordings, but we started collecting some data in terms of here in Florida, what is happening. So you've already seen that. That was a lot of what this morning already consistent of. This is only a small amount of the information that already exists. And just to kind of highlight, there's some great initiatives related to the greater Orlando area. We've already seen that this morning. There's some in Homestead, which are in terms of connecting different organizations and farms as well as restaurants to places where they can have access to food before it becomes wasted. Likewise in Miami, it's not a mandatory composting regulations, but we have had some conversations with the local governments there, and they do have an initiative in mind related to zero waste where they're hoping to also incorporate food waste and food waste composting. So this is just some of the information that we've gathered so far through this project, and what's really meaningful is a lot of this isn't oftentimes summarized in one sole area. So we're really excited to be able to connect all the different voices and be able to put this together in our report once this project ends towards the end of this year. Some other things that we did is we looked at what's currently happening with actual compost facilities. What are the different types that we have? We put together a small survey, and you'll see some results of that in a little bit. But a few things that we did do is we had several interviews as well with some leading collection, food waste collection services, food waste composting, or just composters and anaerobic digesters that do happen to have any form of waste or a waste management as well related to organic. So it might be land clearing debris or yard trash. We just want to get a sense, what does the current infrastructure look like? Where are we kind of missing in terms of being able to help grow the food waste recovery? Some things that we learned is some of the food waste collection is in terms of issues associated with distances. Some things that we did end up kind of learning from that is the definitions associated with municipal solid waste oftentimes limits the ability for food to actually be recovered. So typically food waste will be included within the definition of MSW. And what that means for you, if you happen to own your own compost facility or you want to operate it, it gets very tricky because that waste does typically need to stay within the county and be managed within a county-owned facility. So now you kind of have missed out on the opportunity to be able to even capture this waste. So we've been doing some surveying to understand if there's any changes to the definition with flow control, and being able to describe composting within that and food waste within that more clearly. Likewise, some of the processing issues that we've heard from these facilities is in terms of not being able to have a consistent definition for compost. There's a big difference between something that's called compost and something that's SDA certified compost. Some of those differences are in terms of how long that compost pile has been sitting out, what's the curing time for it, what temperatures has it reached, what types of nutrient content does it have. And when you talk about compost to the common person, they just think all compost is the same, but there's actually very big differences, and those differences are really meaningful, especially when you produce a product and you're now using it in a different way. We actually talked to some folks at a compost facility who told us that they produce a specialty turf product that they use in the swamp at UF. Go Gators, I'm a Gator alumni. And one thing that they really realized is how much that is such a big, important feedstock in terms of where it's being sold in that market and how they're consistently relying on them. They're traveling over 100 miles just to get that specialty turf material. So there's clearly a big need to be able to describe the definitions for just the compost itself. And then in terms of end markets, the biggest thing is just being able to describe those benefits associated with the different types of compost, and then why you would even want to be able to have that delineated from compost versus SCA versus things like that. So I told you we surveyed a few folks. Some of them were kind enough to give us some of their information. These are the 4 that we've gotten responses so far, so our survey's still active. We have different types of locations, mostly windrows. So windrows are just going to be the most basic style of composting. They are typically kind of triangular in their shape. They'll have some type of mixing and a curing area, but oftentimes they're just exposed out into the environment. And then some static piles that aren't aerated, that means they're not going to be turned as often. But these are different types of facilities that we collected some data from. What we learned is the types of materials that they get are mainly going to be from land clearing debris and from yard trash with some pre-consumer. If you'll notice from these 4, none of them accept post-consumer food waste. And again, that deals with some of the definitions associated with the flow control and how you can actually be able to have access to that. Other reasons why they weren't able to secure any type of flow from post-consumer food waste when we were having our conversations, we learned is just the issues associated with contamination. So there's a lot of plastics, a lot of metals that make their way into that post-consumer, and it makes things really difficult. They actually shared an interesting anecdote. They were at a facility that accepts different types of commercial post food waste, and oddly enough, the McDonald's wrapper biodegraded, but the burger itself was still whole. So I'll let you take whatever you would like from that. But we've had some really good conversations. Some other things that we learned is in terms of what are some of the products that they make. A lot of them are going to try and meet that SCA certified compost because it's just such a high quality material. Again, they have end markets that are willing to travel 100 miles just to be able to collect and be able to have access to that material. Then they also have specialty products, and then most of them will have most of what they produce as mulch just because so much of it is land clearing debris and yard trash. But again, there is going to be some of that topsoil and some of the non-certified compost if they still want to produce it. Some other things that we're looking at as part of this project is being able to understand from our total amount of wasted food in the state, how much do we actually kind of have access to or potentially can have access to for us to be able to have better management, this material circularity idea. We know that there's already some portions that are going to be food waste diverted in terms of being donated. And then we also know that there's going to be some that are already going through the biological treatment. But if you can see, by far, most of what we generate in the state is going to be landfilled. And we only are at about 5 or 10% recycling rate or recovery rate for that food waste. So there's a huge potential in terms of being able to actually take this material out of landfills where it's producing that methane, where it's taking up space, and being able to find a better use for it. One way that we are planning on, again, looking at the environmental impacts is using that concept of life cycle assessment. So whether or not you realized it, I will be giving you a small mini lesson on what LCA is just right now. One thing that we're planning on doing is converting this to more usable, kind of user-friendly pieces of information. So what you see here is an example for greenhouse gases. Oftentimes we're going to talk about CO2 for greenhouse gases, and there's many different types of greenhouse gases, so you'll see the term equivalent because they need to be able to account for all the different types. And what we'll do is we'll consider this per a ton of material. So per ton of food waste, what happens in the greenhouse gas sphere when it's going to be collected, when it'll be landfilled, when it'll be combusted, and then when it'll be composted, because that's ideally the situations that we're considering in our material circularity situations. There's different tools to do that. So some of you might be familiar with the US EPA WARM model. The WARM model is one of those really simple, user-friendly tools that anybody can go and have access to, and you could be able to get an estimate for energy and for greenhouse gases for food waste, as well as different categories of food waste. So maybe you could see dairy, vegetables, meats, non-vegetable, leaves, grass, also other types of organics, and many other types of components in our waste stream, and to be able to understand what is the impact associated with producing it, what's the impact associated with collecting it, if you were to recycle it or compost or take it and have it anaerobically digested, if it ends up at a landfill in Florida versus a landfill in California, there's differences in our rain, for example. All of those types of assumptions are going to be made for you so that you can have easy access to this one number that you can use. Another tool that's a little bit more complicated, and that's because you're able to have more flexibility with the definitions and assumptions that go in there, is the North Carolina State SWF, Solid Waste Optimization Framework. We're going to be using as part of this research kind of both of these, but today I want to give you a little bit of insight on how this actually makes its way in terms of a meaningful number. So this is a piece of information that you'll see for all different types of ways for us to manage our waste stream. The one I want you to focus on is the highlighted one. So what happens when you take your food waste and you send it to a compost facility, and then from that compost facility, what are going to be our sources associated with why we have a greenhouse gas footprint, or why we maybe have less of a greenhouse gas footprint? What you'll notice is there's an emissions and an offsets location, or I guess table. Within emissions, as you have food waste and it's going to be treated in a compost facility, oftentimes you're still going to have some type of methane, because remember, food waste still needs to degrade and decompose, even if you're doing it intentionally within a biological system so you can make compost, you still have that release of those emissions. Another source of emissions that you're going to see is you have equipment. That heavy equipment needs to operate on some source of energy. So maybe you'll have electricity, you'll have some type of fuel that's going to be consumed. Now you need to also consider the emissions associated with that system. But one thing that's really unique to the fact that you're producing food waste is you're now going to be able to increase a certain type of availability, which is the availability of carbon in your soil. So you get to have what we call an offset. So that offset is designated as a negative number. So it gets to kind of have an offset associated with your emissions and gets to decrease or lower your total number. So what you'll see now in kind of this slide is a summary of what that means. So how are you able to actually estimate your benefits? It's by looking at your total emissions associated with your system and then the total benefits you get from your system and taking the net of those. Some of the benefits are going to be associated with the carbon storage, but remember, you just created a fertilizer. Now you don't have to go and mine material so you can produce phosphoric acid, for example, here being Florida and having so much availability to phosphate ore, we produce so much phosphoric acid. We don't need to go and mine for those types of rocks. We can now use our food waste as that source and now avoid having to go and mine those things in the first place as well. So there's a lot of benefits that come from food waste, and we could kind of see that here. So this gives you an idea. Remember that offset is going to be designated as a negative number. Then the emissions are going to be a positive number. So the fugitive emissions, your food waste is still going to degrade. It's still going to make its way into our release of greenhouse gas emissions, even if it's in a controlled environment. So that's what that red number is. And then we have to still transport, we have to turn our piles. There's still going to be an emissions associated with the fossil fuels that we consume to be able to operate that equipment. But by far and large, the benefits from fertilizer offset and then the soil carbon that you get are going to be able to result in a net negative number. That means that you will have a net negative or a really good offset associated with having that food waste managed in that way. So these are some of the things that we're working on. We're still not done. Just wanted to give you guys kind of an idea of some of that information. The last thing that we were able to collect some data on, this is very recent data, is on some of the cost aspects. So what does it look like for you if you were in California, for example, and you happen to have a location that allows you to participate in composting at home? That compost cost is about $10 to $20 per month, and your total monthly cost is about I want to say $30 to $55 per month. So this is their current kind of numbers. If you had a 90-gallon cart, if you had collection, that was about once a week for that food waste, and if you were on that side of our coast. So the last thing I'll leave you with is just kind of this quick summary document to give you a sense of where we're at and what we're planning on doing. We're still collecting a lot of data, still planning on looking at kind of the benefits associated with our specific system that we set up and really trying to understand and hear from the different stakeholders like yourselves what's important and what we should be conveying as part of this research so that there's more usefulness in terms of policy and practical application. One thing that I will share is we're still collecting data on compost facilities, so if you know one or if you have access to one, please feel free to share this. We're hoping to kind of finalize that information in the next month or so. Thank you, guys. Did I go too fast?
No, we're fine. Questions?
So one of the things that kind of go along with this is, as an added, just so folks know, check with your local counties, because I know there are a couple of them out there that have backyard composting programs. Hillsborough County, Orange County, Hernando County have backyard composting programs, and that's a really great way if infrastructure isn't in place in your community that you can get a jump on that. Mm-hmm. And as a former recycling coordinator, I knew I took credit for it in the annual report. Yay, April 1st. And the other thing is that the city of Gainesville has some requirements for commercial composting, and that infrastructure with folks like O-Town Compost and Beaten Path are now starting to come into play. So there are some more avenues that people may not know about it. Hillsborough County does a great job with their composting program. It's pretty phenomenal what they do on an industrial scale. So no question, just comment.
Good comment.
Mine's also more of a comment, but I just want to say thank you to you and your students and everybody who works on this, because as a city employee, and I'm sure if anybody else in here works for local government, it can be challenging to get all the information you need to prove why something makes sense for the city to move forward with, and there's so much red tape that can be in the way. So having this research readily available for us to use, pull numbers from, plug our numbers in, is just so extremely important. And usually there's not too many staff members who are trying to make these things happen. So our time is very stretched. So I really appreciate the work you're doing.
We appreciate you always giving us feedback and information and data to share.
Speaking of students, will you raise your hands, please? I just want to tell you from the oldest person in this room, thank you very much, because we really need younger people to get involved in this industry. So thank you. All right, if there are no other questions, I'm sorry, Meg.
Sorry, I'm going to be bold and say this. Is there a way to completely eliminate, I guess, the risk of like emissions by reusing that methane gas that comes from the composting material we save?
So there are some designs where you can take that methane and produce electricity from it. So you can scrub it and then be able to use it within like an engine or a turbine, and now you have electricity generation. But for the most part, you can never really get away from the fact that you will have those fugitive emissions, the ones that you can't capture. But yeah, it'd be nice though. Yeah.
Great presentation. We saw the food waste management hierarchy earlier, like the avoiding all the way down to disposal. Is there any interest to do like a life cycle analysis for those different stages? I know we're kind of composting, but like AD through prevention, the food recovery.
So as part of this research, we're going to be limited on just end-of-life management, but there's always interest in terms of looking at the upstream, what happens to it. I know warm, so if any of you guys are looking for a quick way just to be able to gauge what are the benefits associated with you actually diverting that material and turning it back into food that's going to be consumed, they have a number called source reduced or production, and you can actually use that number associated with your mass estimate for how much you captured, and now you could say, here's how much greenhouse gas and energy I'm benefiting from that donation. They haven't looked at other indicators, so life cycle assessment is very comprehensive. It looks at things like human toxicity, eutrophication, which is kind of that greening of the water that we see, for example, in Lake Okeechobee, or even if you walk around here sometimes. Acidification, which is like acid rain. There's many other indicators that are important within life cycle assessment, but WARM only focuses on greenhouse gases and energy. Eventually, it'd be nice for us to also look at that too.
That'd be great to quantify those benefits.
Yeah, for sure.
Hang on.
This question isn't so much for our presenter as for the people in the room that deal with solid waste. One of the reasons why our backyard fruit recovery program grew is that we actually had a municipal collection that wouldn't allow fruit in the yard waste collection. And so my thought is, you already have trucks that are picking them up. You're putting them in a facility that's creating a quote-unquote compost. Why is that a limitation, and how can we increase knowledge through municipal waste collection to start to include the food waste? Let's start with the fruit, which doesn't have a wrapper. I know the problems with food waste collections in municipalities is the can, the wrapper, the plastic that it comes in, but fruit doesn't have a wrapper.
Does anybody from local government want to answer? As I am not a local government.
Carm? Hang on.
So as a former county employee managing a solid waste system, the number one answer to your question is the definition of what municipal solid waste is. When we look at yard waste collection, it varies from county to county and how that's maintained, and that has a lot to do with it. Yes, what you're talking about when you say a backyard orange tree, that maybe that tree has the graft has gone bad, and you have the bitter orange tree that you started with, and it's producing fruit. You have a lot of it, and you're going, that's a no-brainer. You know, I can put that right in, but it has to do with the management of that material and what we do, because compost requires very specific guidelines in state statute to be met. You have to make sure you hit temperature numbers, and you have a time frame, and a lot of counties don't want to get into that. Again, I work for 2 counties. One now, Hernando County, is involved in a small composting program because of the USDA grant. They got a trommel screen. So now they're looking at just wood waste and eventually putting in food waste, but it's permitting and definition.
I will say that food waste is difficult to manage. Once you receive it at a site, especially for recycling or composting, you have to incorporate it or remove it within 48 hours. So that time frame makes it extremely restrictive to recycle it timely, because it is considered a putrescible waste. It attracts birds. It's very stinky. And so in that sense, yard waste is a lot easier to manage, has longer hold times.
All right, last point of view. But for us, our yard waste gets composted with Veranza. So if you were on that tour, you saw that that's where all of the City of Tampa yard waste goes. But we have a contract with them that only accepts yard waste. So they're not processing food waste on that scale. And when you open up to the public, you're looking at lots of room for contamination. Even if we just say like, oh, now we're accepting fruit from your trees in your backyard, you're going to see packages of strawberries and all those things end up in that waste stream. So it gets very scary for companies to try and throw off that extremely particular balance like Carmen was saying. But our contract doesn't allow for that, so we have to follow those rules to keep it composted.
Okay. Well, if there are no other comments, it is lunchtime. Oh, wait a minute, we got one more. Psych.
You had mentioned capturing the methane and utilizing that to translate into electricity. I think that's super interesting. Do you know if there's like any examples here in the state of any composting facility that's doing something along those lines, or?
So there's one anaerobic digestion facility that is, I think they have plans for construction and to be able to operate in that way. But in terms of any of the compost facilities, not so much. There are a few wastewater treatment facilities that are capturing some of that energy. For example, City of Tampa, I think you guys have an anaerobic digester, and then they'll be able to produce electricity from it. I'm not sure if you're just flaring it or if you're producing electricity, but I know, yeah, they're flaring it, yeah. So it's still limited, yeah.
All right, hang on one sec.
So there was a facility in the middle of the state in the Orlando area that was set up to take food waste and do anaerobic digestion with it. And I don't know if it was the mechanics of the process or the mechanics of the company, but they are, I believe, no longer operating, and they had food waste coming from a large volume generator. And again, you get into the same problems we have with regular curbside recycling and industrial recycling. There were some contamination issues that went along with it, but that facility has been mothballed or, I believe, dismantled.
There are some facilities that are doing MSW, right? Municipal solid waste. That's more landfill.
Yeah, landfill-wise, there are a lot that are collecting the methane and producing electricity from it, or compressed natural gas. Yeah.
Yeah, this kind of goes back to her question about the commingling of food waste with yard waste. Yeah, while you need to kind of have those controls in place to reduce pathogens and destroy fly larvae and weed seeds, in my hometown of Portland, Oregon, I have toured a couple municipal compost sites, and in Portland, the curbside compost bin, allows the commingling of food waste, soiled paper products, and yard waste. And sure, they're not Florida, they're not a greenhouse state, but it's really cool to see all that material get diverted, and it makes it pretty simple for people, but there is about a 5% contamination rate, and that for some composters is just not acceptable. So.
We did have one question from one of our virtual attendees, and I think it was for Karina, correct? Right.
Correct. That question is, how does Orange County fund the food scrap collection for composting?
The food collection is, that's all done through the USDA grant. So we received funding from a grant to be able to do that.
Yeah, so that Orange County program, our goal as the hauler was to ultimately have composting seen as a utility alongside trash and recycling and come from the general fund, and not, be this feel-good service that comes from grant funding. So, stay tuned. There might be some exciting news about how the funding will be changed. So.
All right, if I'm hearing no other questions, I get to do, this is a cool room, and let me show you why. We're going to get to have a chance to eat lunch, and you'll be able to see outside for a change. So with that, hopefully it'll warm it up a little bit in here. It's cold. So lunch is out here. Help yourselves. We're going to come back in here and sit and eat, okay? Thank you. Thank you, Malak. And also as a reminder, we've got bins here for leftover food waste.